This monochrome grid represents the default state of our personal computing. Information is trapped in isolated vertical silos, email, CRMs, and calendars, where data packets fall into disconnected channels and never intersect. For an AI agent, this fragmentation creates a constant bottleneck. Without a unified view, the agent must reconstruct your context from scratch for every new interaction. This architecture leads to memory loss and hallucinations. The agent lacks a durable, centralized source of truth to anchor its operations. Solving this fragmentation requires shifting focus from the application layer to the infrastructure layer, placing the person at the center of the data flow. Durable AI agency depends on a memory foundation that persists independently of any software vendor. PIOS 2.0 is an open framework for owner-controlled personal information infrastructure. The architecture relies on a strict division. On the left, we track the raw state of what happened. On the right, the derived interpretation of what it means. Most standard software collapses these two vital layers. When a record is updated, the system often overwrites the past, changing the underlying evidence. PIOS isolates these layers to ensure the original data foundation remains pure and perfectly accessible to any authorized AI agent. This structural decoupling is the required engineering standard for any system acting as a sovereign personal core. The pipeline begins at the entry point. Whether dealing with API calls, sensor streams, or file uploads, all information routes into a single universal inbox. The ingestion rule is to capture first and organize later. Input lines converge into the universal inbox, so data is secured immediately, without waiting for a perfect schema. An inbox agent triages these incoming packets. It preserves the original file and generates a minimal initial event record to establish provenance. Complex enrichment and metadata extraction happen asynchronously in the background. This prevents ingestion bottlenecks and keeps the pipeline moving. Funneling all data through an asynchronous inbox ensures that no personal context is lost due to classification errors during the initial capture. Information leaving the inbox is distributed across 5 strict data zones: originals, events, knowledge, derived, and system. Zone 1 contains the originals. These are policy immutable files stored exactly as received and permanently frozen. Zone 2 is the events row. This is the append-only canonical spine that records every system occurrence in a continuous, unchangeable sequence. Zone 3 holds knowledge. These are mutable but traceable semantic files that represent the people, projects, and concepts in the user's life. Zone 4 contains derived data. These are rebuildable outputs like Parquet files or vector embeddings, optimized for high-speed analysis. Zone 5 is the system layer. It stores the operational definitions, agent runtimes, and governance rules that manage the other 4 zones. Agents query these zones strategically based on the requirement, accessing raw proof in the originals, temporal history in the events, or context in the knowledge layer. Segmenting data by its physical mutability and function prevents agents from accidentally corrupting the sovereign foundation. While traditional databases often overwrite historical state, the PIOS event log functions as an append-only spine. Rollback is achieved by writing a new correction event. This ensures the audit trail of what the system previously believed is never erased. This JSON event envelope carries the minimal stable schema required to prove provenance. It distinguishes between occurred time, when a reality happened in the world, and recorded time, when the system actually captured the data. There is also the primary created time. This marks the exact moment the system promoted the raw source into an actionable core record. Separating these timestamps is mandatory to prevent an AI from confusing ingestion time with the actual time of the event. Transitioning from plumbing to meaning, we look at Cotton, the non-technical context blueprint. Cotton provides the governing rules for naming, grouping, and relating personal information. It guides agents through principles rather than locking them into a rigid database schema. The default container for this meaning is a markdown file with YAML front matter. It is universally portable, human-readable, and easily parsed by language models. Cotton uses 3 primary organizing lenses to classify all information: myself, my world, and my system. Myself covers the owner's identity, private facts, and personal preferences. My world handles external context, such as relationships, organizations, assets, and active projects. My system manages the operational machinery, including agent profiles, processing manifests, and connector states. Kotlin also defines information stability layers, which signal how frequently an agent should expect data to change. This distinguishes stable information, like origin facts, from dynamic information, like active tasks and calendar events. Combining human-readable Markdown with these organizational lenses provides agents with semantic guidance without proprietary lock-in. Efficient retrieval is supported by the update-first owner history. When meaningful work reaches completion, the system generates a structured update manifest. This prevents agents from having to scan through raw chat logs and command line traces to understand what occurred on a given day. Agents navigate this through a time-zoomable history tree. The highlight moves from broad yearly summaries down into quarterly, monthly, and weekly aggregations. An agent isolates a specific day, drilling down into the underlying event and the immutable original file for verification. This summary-first retrieval minimizes token context waste, allowing agents to reconstruct reality with speed and precision. Absolute user sovereignty is anchored by the core bundle. This ensures personal data is never trapped within a specific cloud provider's managed service. As this directory tree demonstrates, a full core export bundle is simply a versioned collage-to-lev Markdown files, YAML manifests, and raw originals. This bundle, paired with a provisioning manifest, allows a user to instantly rebuild their entire agentic context on a new server or a local machine. This shifts the burden of memory from the service provider to the user. Agents operate securely inside your foundation, rather than accessing context fragments scattered across third-party applications. PIOS 2.0 provides the structural discipline required to ensure personal data is sovereign, durable, and functional for autonomous AI execution.